Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x minus 1 is equal to 2 to the power of x. Now, if we have something in the form a to the power of m plus n, this can actually be written as a to the power of m times a to the power of n. So as you can see here, we have 3 to the power of x minus 1. This can be written as 3 to the power of x times 3 to the power of negative 1. And this is equal to 2 to the power of x. Now I'm actually going to divide by 2 to the power of x on both sides. So now we have 3 to the power of x. And I'm actually going to move the 3 to the power of negative 1 to the denominator, and now it's going to be 3 to the power of positive 1. So now we have 3 to the power of positive 1 times 2 to the power of x. This is equal to 1. Now I'm actually going to multiply both sides by 3. So now these two cancel out, and you're left with 3 to the power of x over 2 to the power of x is equal to 3. So now this can be written as 3 over 2 to the power of x is equal to 3. Now if I take the ln of both sides, you get this can actually be moved to the front of the ln because this is an important property of logarithms. So now we have x ln 3 over 2 is equal to ln 3. And now I'm actually going to divide both sides by ln 3 over 2 so I can isolate x. So now these two cancel out, and we are left with x is equal to ln 3 over ln 3 over 2. Now, although this is a fine answer, this can actually be simplified because if we have something in the form ln a over b, this is actually equal to ln a minus ln b. So ln 3 over 2, this would equal ln 3 over ln 3 minus ln 2. So this is our answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 16 to the power of x plus 20 to the power of x is equal to 25 to the power of x. Now what I'm first going to do is I'm going to divide both sides by 16 to the power of x. So these two would cancel out, and on our left-hand side we have 1 plus 20 over 16, which is 5 over 4. To the power of x is equal to 25 over 16 to the power of x. Now, 25 over 16, well, this is equal to 5 over 4 squared. So squared, and now we have this to the power of x. And this is equal to 1 plus 5 over 4 to the power of x. So now what we're going to do is I'm going to let 5 over 4 to the power of x equal t. So I'm going to assign it to the variable t. And this can actually be, instead of 2 to the power of x, I can actually also write this as x to the power of 2. So I can flip this positions. So now if I replace 5 over the power of x with t, I get 1 plus t is equal to t squared. So now if I subtract t and 1 on both sides, I get 0 is equal to t squared minus t minus 1. And if I plug this into the quadratic formula and factor this, I would get t is equal to 1 plus or minus the square root of 5 over 2. So this means that we already have our value for t, 5 over 4 to the power of x. So this means that 5 over 4 to the power of x is equal to 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. So let's first do 1 plus the square root of 5 over 2. So we have 1 plus the square root of 5 over 2. Now to solve this, I'm actually going to take the ln of both sides. So if I take the ln of both sides, well, now I could move the x to the front of the ln. So this would be x ln 5 over 4 is equal to ln 1 plus the square root of 5 over 2. So now if I divide ln 5 over 4 on both sides, these two cancel out, and I get x is equal to ln 1 plus the square roots of 5 over 2. This is actually 1 plus or minus square root of 5 over 2 over ln 5 over 4. So this is our answer.